Alright, so here's the 10.2 video for vocabulary. I'm going to take some notes on it. Much like 10.1, 10.2 is also vocabulary heavy. So we have a lot of new words to get familiar with. So we're going to talk about these: central angle, minor arc, major arc, semicircle, measure of a minor arc, measure of a major arc, adjacent arcs, congruent circles, congruent arcs, and similar arcs. Alright, so we're going to start with just some core concepts here. And it says the measure of a minor arc is the measure of its central angle. Well, a central angle is the angle at the vertex here. So this is the central angle. And you imagine any angle right here, well, that's going to be the same measure of the arc that it creates on the circle. So yeah, there's an angle. We call it angle C in this case. Angle C equals 50 degrees, the measurement of it. Well, the arc it creates is also 50 degrees. But this is the notation, the symbol we use for writing a minor arc. And a minor arc is anything that is less than 180 degrees around a circle. So again, the central angle that's at the center, it's the vertex at the center, that is going to be equal to this arc that's created on the circle. You can kind of imagine it of like a pizza crust. Like if you have a piece of pizza, the tip of the pizza, the tip angle equals the crust arc. So that's how it's going to work. They're going to be the same measurement. This here and this. The notation is going to be different. So the measure of the entire circle is 360 degrees. So if this is 50, the whole thing adds up to 360. The measure of a major arc is the difference of the 360 and the measure of the related minor arc. So if we wanted to look at the major arc for this circle, here's the 50 out of here. The major arc is this way around it. And the difference here, the major arc, you need to use 3 letters. So you're going to see and it kind of maps it out for you. I go from A to D is next to B. So I use all 3 letters of that to kind of figure out which way I'm going to identify that arc. And we know that that arc is just going to be, well, 360 is the entire circle. If we take away what the minor arc was, which is 50, we're going to be left with that 310. So major things to remember here. Minor arc, you're going to use 2 letters, 2 points. Let's say points instead. And we also know that it's always less than 180 degrees. And then we have the major arc. And that's using 3 points, and it's always greater than 180. Okay? And there you have it. So that's kind of exploring minor and major arc. Another one that's on your notes up there was semicircle. And a semicircle is just, if I had a circle here, it would be this arc that is half of the circle. So semicircle is always, if you called it like A, B, I'd say measurement of arc AB here equals 180 degrees. A semicircle always equals 180 degrees. It's half of the circle. All right, let me just jump, make sure. Okay, good. All right, so let's get into some postulates here. Postulate 10.1, also called the arc addition postulate, states that the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. So we have this major arc here. I'm going to do it in green. It goes A, B, C. So it's talking, make sure you go that direction that the letters are written in. So A, B, C is that major arc. Well, it equals the two minor arcs added up. So it's equaling AB, which is here, plus BC. Okay? And these are the two minor arcs. And we'll see how that's going to work in a few of your problems. All right, keep moving on. Theorem 10.3, congruent circles theorem. Two circles are congruent circles if and only they have the same radius. So that just means that if the radius is the same, in this case AC, if that's equal to BD, then they have to be congruent circles. Meaning they'll really look like the same size. All right, and your congruent central angles theorem. And on the same circle, or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. So BC, the arc BC is congruent to DE if and only BAC is congruent to DAE. Well, that makes sense because we can see that these are actually vertical angles here. So BAC here, that's clearly congruent to DAE here by vertical angles. So it would make sense that their arcs, therefore, are also congruent. And we'll see how that works. You'll be able to tell in a few examples. 10.5, well, guess what? All circles are similar, meaning all circles are the same shape because they're all the same, they're all circles, but they're different sizes. So that, remember, is our definition of similarity. Just want to write that. All circles are the same shape, but can be different sizes. All circles are similar. All right, so that is just kind of the beginning. Let me jump back here, make sure. Oh, one other thing, adjacent arcs. So adjacent arcs are just arcs that are next to each other. So an example of that, if I kind of jump down here to this, I'm going to just add this. These are also, since AB and BC are next to each other, these are also, we could refer them as adjacent arcs. Other things here too, congruent circles, congruent arcs, similar arcs. So similar arcs, we'll kind of go over what that looks like in some examples on the next video.